Welcome to another video on smart architectural programming. My name is Mohammed, and coding alongside me is George.
And basically today we'll be going over Python file management. I'll let you take over.
So, today's video is basically going to be focusing on how we can efficiently move our files using the file management techniques in the Shutil module. Now, this video covers essential process of moving files from one location to another within your file system. And starting with a basic introduction of the Shutil module, we'll be able to understand a very simple method within the Shutil module we're using which we can transfer files from one folder to another using Python. We also demonstrate various scenarios of moving the files, including handling file existence and error situations gracefully. Now, like with every other video that we did in this channel, we'll be having three examples here, right? And all of these three examples would expose you to new further concepts. Particularly, the first coded example that you can probably see on our screen right now is just the simple implementation of using a shooter modules to move file from one folder to another. Second would be dealing with how we can identify file existence, whether the file is present within the folder or not. Here we're trying to be defensive in our programming to make sure an error does not break our code, because Python is going to quite literally take our word for it that the file exists. That's why we mentioned that to move that file from one place to another. And if it doesn't exist, our code would break. And third example would be dealing with another way to do a much more effective defensive programming, by which we're dealing with as many as errors as possible, making sure that even if all the errors in the world are raised, our program doesn't break; it just keeps on working, right? And basically, that's the three different examples we will be covering. And by the end of the video, we expect that you should have a solid understanding of leveraging the Shutil module to manage file movements across our Python projects. Uh, Whether you're a beginner or an experienced Python developer, mastering file management operations is very key. And this is the among many other videos we have created specifically targeting file management operations or file system operations, like file deletion, so on and so forth, because these are this is a very specialized niche component. But if you want to become a programmer within a large corporation, or just become a professional programmer, this is an important niche to understand before moving forward. So with that, we'll move on to our first example that we're going to be going over. That is basically using the Shutil modules Shutil.move method to transfer file from one folder to another. So we import the Shutil module on line one, like every other uh, module that we import. It's imported right at the top. Again, I won't go over the exact details about the Shutil module. If you want to learn more about it, open the Shutil module documentation on the internet. Google it, you'll find the documentation. And as a side note here, I want everyone to remember, like within our videos, we go over a lot of different Python modules, right? Shutil, OS, so on and so forth. You see a new module, pause the video, open the documentation, get an understanding. Don't go too deep into the documentation. Just get an understanding what that module covers. It has a, like, what is the broad theme of that module, right? What are the broad aspects that it helps you dealing with certain aspects of Python that it could help you deal with, basically. So just open, get a documentation, take a brief look at what it does broadly, and keep that in your mind. Because then, moving forward, if you potentially need to do something, and you have the broad themes of these libraries in your head, for example, if you are working with, let's say, um, if you want to do something on your computer, right? So if you know about the OS library, or you just have the brief summary of like understanding of that in your head, you can immediately say there must be a solution in the OS library that I can open the documentation and find to do a certain action that I want to do within my computer environment. So with that out of the way, we move on to the next part of our code from line 3 to 5. Here you'll notice that we're defining our source and destination paths. So where is the file that we want to move, and where is the folder where we want to move it to. So where is the file? By that we mean where in which folder is the file that we want to, and then destination path is where in which folder where we need to move the file to, basically. So in both cases we define variable called source path and destination path, and within both of these variables we define the folder locations using string, basically. So once that's done, on line 7 onwards to 8, you'll notice we're using the Shutil dot move method of the Shutil module, where we play the dot move methods inputs are source path and destination path. We give them that, and nothing else needs to be done. We run this code, and we basically move our file from the source path to the destination path. And line 10, we just print that the file was moved successfully on the console. So that is a very simple way you can move file from one place to another. Now, moving on to the second coding example, just giving you a brief introduction about this code, is that we need, like when we're moving a file, right? If you watched our video on file system deletion operations, you'll understand that before moving a particular file, we need to understand whether that file exists or not. Like that's a very pertinent question, because computer is something. Imagine the computer is your naive little brother, right? And he takes whatever you tell him as truth. And if you tell him something is there, he'll believe it, and he'll say, "Yeah, that thing, as you said, is there." And if he doesn't find that thing, that code is going to break down, right? Just like your little brother might lose his trust in you, the computer itself stops working. The code throws an error, and your software stops working. So this is the least desirable outcome as a programmer that you want once your program is out there. So how do you avoid that? Like the previous code that we used, if the file doesn't exist, it's going to break down. If the folder is not there, it's going to break down. So like we did in our video on uh, file deletion system operations, we are going to import the OS library. That's a very important library. I mean, if you don't want to look over every library that you see in our video, because there are a lot of libraries that we go over related to Python. Um, but this is one library you have to go and understand, because it helps you dealing with a lot of different tasks related to your computing environment. So please stop the video. If you're not familiar with the OS library, go read up on that library, understand that library, what it does, what it provides. Don't go too deep into it. Just understand basically what are the different solutions that the OS library provides. What is the broad theme? Moving forward, once you import the Shutil and the OS libraries on line 1 and 2, uh, we move to line 4, and basically between line 4 and 5 we again used source path and destination path variables, where we define the source and destination paths for the file. Now we're doing a bit of defensive programming here, is we're using from line 7 onwards an if statement to check if os.path.exist is a method in the OS library that checks whether a file exists or not, or whether a path is valid or not, or if the path is not valid or the file already exists. In this case, if the path is valid and the file exists, we are removing that file, and we use the os.remove method to remove that. It's very necessary because conflict of similar files might cause an error in your code at this stage. And then we use this on line 12 and 13. Use the same method as we used previously, using shutil.move, and move the file from the source path to the destination path, and then print file was moved successfully. All this piece of code between 7 to 10 is doing is making sure that we have a defense prepared. This is something we call defensive programming. We have a defense prepared to make sure our program doesn't crash. So basically that's all we're doing. We're making sure if an error comes up, if a similar file is there, if a similar file is not there, we somehow make sure let the computer know that if it doesn't exist, do this instead of just doing what we're telling you to do, basically. So with that out of the way, I mean, this is a very flawed defensive programming, because we just have one if statement that is just checking one aspect of a potential error. But potentially, the most efficient way to do error handling is the try and accept blocks, basically. And that is basically the most comprehensive way that you can, you know, cater for every and all potential errors that might be risen. Like at least 90% of those errors could be dealt with using the try and accept blocks. I mean, you can do it other ways as well, but it's probably the most efficient and easiest way to do defensive programming. So the last example we're going over is basically just that, using try and accept blocks to handle for all potential errors to make sure your program keeps on running regardless of how many errors could pop up in between that. I mean, if you're working in a on a project for a big corporation, the corporation does not want it has multiple processes within the same software. The corporation doesn't want your one error to stop the entire program. They want that error to be noticed, but they don't want the entire program to stop working. So in that case, we need to make sure the program keeps on working even if certain errors of certain certain code do pop up. And that's what we're going to do here. On line 1, we import Shutil. We again on line 3 and 4 define the source and destination paths in variables. And then line 6 to 14, we use the try and accept blocks. So in line 6, we try, and try basically means that the computer gives it an effort to go over this piece of code under this block uh, to see if it can run that code successfully. If it doesn't, then we use the accept blocks to deal with other situations. So here we use shutil.move to move a file from the source to the destination path and print the file. If that shutil.move worked properly, we print file was moved successfully. Now, potentially, I'm making an assumption that two main errors are going to rise up here, but we're dealing with three except blocks here, and I'll go on to the third one in a while. So potentially, one error could be that the file was not found at the source path, as we talked about in the os.path.exist. If the file isn't found at the source destination, that's an error. So if that error is raised, we deal with that using the except file not found error on line 9. And under that, within the except block, we print source file was not found. So basically, it means that the code keeps on running without stopping if the file was not found. Similarly, another error that could be risen is that the file is there in the source path, but we don't have permissions to move that file from the source path to anywhere, basically. Or potentially, we can move that file from the source path, but we don't have permissions to add or remove anything from the destination path. So in this case, we might have a permission error. So in the except block, the second except block, we deal with the permission error on line 11, where we print permission was denied to move the file. And the last except block is our general purpose except block that deals with any and all things that are any and all error rather that appear, which were not file not found errors or permission errors. Basically, any error that pops up that is not file not found or permission error from the shooter.move method, it's going to be dealt with our last except block, which is exception as E. It deals with all exceptions, and we just print an error occurred and mention what sort of error occurred using the print statement. With that, we can wrap up our video on file system operations, particularly dealing with moving files from one folder to another within Python. George, would you like to add anything at the end?
No, I think you covered everything. Just comment in the comment section if you all need to go over any other topics. And thanks again.
And we will see you in our next video.